And here we go. We have liftoff.
Propulsion continues to be normal.
RCPA chamber pressure looks good.
Following up. Roger, roll, Atlantis.
Water towers fly! Yes!
Tango down phenomenal.
Fighting downside FD off. Bring in FD off. Off. It's orange! 145!
Oh my god! Oh my god!
Decollage.
Look at this!
Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This methane will be igniting in the flare, correct?
Yikes. You dead? We don't need any more of these.
Hello everyone, you are looking at a live shot of Falcon 9 atop Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida, where a batch of Starlink satellites are getting ready to go to low Earth orbit. My name is Hagen Warren, I'm an editor here at NASASpaceflight, and I'm going to be your host for tonight's NSF broadcast of the launch of Starlink Group 6-74. Joining me today on comms is Mr. Sawyer Rosenstein. Sawyer, how you doing?
I am doing fantastic. There's a rocket out on a launch pad, and it's just about ready to go. That means it's a good day, right?
Absolutely. As I often say, any night with a rocket launch is a good night. So, also out in the field tonight is Mr. Max Evans. Max, what's up?
Good evening, everybody. Yeah, it's been a minute since we've done this. It's been a rather slow week, but we are always happy to be back, and we are looking forward to seeing Falcon 9 off tonight.
Yeah, and as you can see, sitting right next to Max is D Wise. D isn't on comms tonight, but it's definitely out there going to be getting some awesome shots. And then also in the background, operating today's stream is Chris Atherton, pushing those buttons, pulling the levers, making sure y'all can hear us, and that you get these beautiful shots of Falcon 9. So, Sawyer, do you want to run through today's mission? I mean, it's a Starlink, but still, run us through it.
Always not your ordinary Starlink, right? Until it becomes ordinary. The day it does, though, we're in trouble. But this one is going there with the higher batch of satellites that has become a very recent thing for SpaceX with the V2 Minis. There are 28 of the Starlink V2 Minis on this 6-74 mission, which means those are all going to be the regular V2 Minis, not the direct-to-cells, as those are a little bit on the heavier side. So to be able to fit that many in, they're all the regular satellites. As with most of the Group 6 missions, so the 6- missions, this one is a 43-degree orbit that it will be going into, so it will be heading southeasterly for this flight. So it may sound ordinary, but 28 Starlink satellites is tied for the most number of Starlink V2 Mini satellites, because it was just recently set at 28.
Very cool, very cool. As usual, as we do it here on these NSF streams, if you have any questions for us, be sure to tag us with @NASASpaceflight in chat, followed by your question, puts it in a nice queue for us, and maybe I'll be able to ask either Max or Sawyer your question. So, yeah, actually, let's go to Max. Max, how's the weather looking out at the Cape tonight?
You know what, Hagen? It is looking rather marvelous tonight. We are currently targeting at the opening of the window, and the weather right now is greater than 95% favorable, which really is about as good as a weather forecast can get. The risk, warnings are low for high altitude winds, booster recovery, and everything else in the area. So really, weather is looking as good as it can get. Little light clouds above us, but that should be clearing here momentarily. And because there is no moon out tonight, we have a lot of stars above our heads easily visible. So it is an absolutely gorgeous evening here at the Kennedy Space Center.
That is awesome to hear. So yeah, I guess, do you want to get into a little bit more about the booster that's flying today's mission and its trajectory, Sawyer?
Absolutely, we can. So, this particular booster, again, we talked about the trajectory going towards the southeast, but this particular booster that will be going southeast is the nicest booster in the fleet, in that it is booster 1069. Go ahead, insert your jokes. Apologies already for all the chat moderators. This
Nice.
mission has previously flown, as you see there on your screen, CRS-24 to the ISS 4-23, Hotbird 13F, OneWeb 15, Starlink Group 5-3, SES 18/19, that was one mission, 5-6, 5-12, 6-9, yes, 69 did 6-9, 6-19, 6-28, 6-36, 39-47, 57, 10-1, 10-9, 8-10, 10-8, 6-66, 12-3, 12-21, and now, most recently, Group 6-74. So, again, for those wanting to see where this booster will land, it will land on a shortfall of gravitas, located downrange towards the southeast. So, not in the Bahamas, but kind of near the Bahama northeastern part of it. And the fairing recovery vessel is dug because those two fairing halves that you see on the top, those will fall away and actually be recovered and flown again.
Very, very nice. And now, Sawyer, I know that's something that a lot of people have been asking lately is about, we saw that one, I believe it was a Starlink mission, I could be wrong, that actually had a booster land in the Bahamas, but we haven't seen that since. Do we have any insight into what's going on there? Why haven't we been seeing more landings in the Bahamas?
It seems like there's some regulatory paperwork that they're kind of dealing with out there right now. Some environmental things that they need to continue to assess after that first landing attempt. So while they continue to get that paperwork all set up and worked out and deal with all of the environmental assets and issues with it, those are temporarily on hold. Hopefully that gets resolved quickly so we can see more of those closer to the Bahamas landings.
I know that landing that we did see was absolutely gorgeous. So, yeah, hopefully we see those starting back up soon. Yeah, I want to hit some quick support that we've gotten come through the queue here. Alex upgrading to the red team, upgrading his membership. Thank you for that support. If you are interested in becoming a member here at NASASpaceflight, be sure to go to our channel, and there should be a little join button. You can look at all of our different membership levels and the perks that come with them. You can get access to the NSF Discord, some behind-the-scenes videos. So yeah, it's a really cool program. Definitely go look at that. And then Bacon Warrior here with a $5 super chat saying, once again, good evening, NSF crew. Time for the triple header of launches. Hope everyone is doing great. I am doing great. Hope you are also doing great. So thank you for that support. All right, well, coming up here at T-minus 53 minutes to launch, Sawyer, do we want to go through a little bit of what we should be seeing in the countdown for tonight's launch?
Absolutely. So we're still a little bit away from the big part of the action, but right now everything will be sort of prepped at the pad, ready, maybe some occasional venting here and there. The main thing starts at about T-minus 40-ish minutes. That is when they begin the go-no-go poll for fueling. That will take a little bit. Unfortunately, we don't get to hear it because we don't get to hear their comms. And even if we could, they do it all electronically with buttons on their consoles. We should get that go, hopefully, at T-minus 38 minutes. And if so, then fueling begins at T-minus 35 minutes. Of course, starting with Stage 1 with the RP-1, Rocket Propellant 1, the refined form of kerosene, and LOX, liquid oxygen. While Stage 2 begins with just the RP-1, again, slightly warmer than the LOX. I say slightly, obviously, they're all super chilled propellants, which is why they do the quote-unquote late load here with the fuels. That should continue all the way down to T-minus 20 minutes, 20 seconds, when Stage 1 will wrap up with its propellant load. We'll, of course, see that with the best vent, as we like to call it, the T-minus 20 minute, 20 second vent. And then that takes about 4 minutes to chill those lines and start loading in prop shortly after that for the liquid oxygen on Stage 2.
Very, very nice. And, I feel like we're really used to, or rather before Falcon 9 became, had this increased flight cadence, we were so used to seeing a lot of these rockets already have their fuel loaded into the vehicle before launch. So what are some of the advantages to this, as you mentioned, late load? Why does SpaceX pursue it, and what are the advantages of it?
You say that, there's an Atlas V out there that has some of its propellants already loaded into it before it even, as soon as it gets out to the pad. So you've got the Atlas V for Kuiper 1 kind of hanging out with some prop that it deals with. Obviously, the super cooled stuff, or the cooled stuff, comes later. The reason that SpaceX waits to do their late load is because everything is super chilled. So there's to the point where these gases become liquids. And then you can make them even colder than that, which densifies them a little bit more. As a result, that means that you can squeeze more propellant into the same amount of area. The difference being, though, the rate at which those will boil off is a lot quicker. So you kind of basically have to load and go, which is why it's called a load and go procedure. Otherwise, it's going to boil off very quickly, and then topping it off is going to be a pain. So basically, you get it that absolutely crazy cold, load it in, and go right away, as opposed to the other one, which allows you to wait longer. So say if you start fueling and see something wrong, you can kind of hold off. But you're also not getting as much efficiency out of that propellant.
Definitely. It's a unique thing to see. It's also, I know at the time whenever they came up with it was kind of controversial a little bit. It took a while for NASA to get okay with it, especially with crew flights. But very cool to see how they've done it. It's definitely a substantial part of them being able to increase their cadence to such an extreme level that we see it now. So
yeah, that was the crazy part, was the idea of, hey, let's load in all of this crazy, dangerous stuff with them on board and have basically zero propellants on board when the crew loads on. With shuttle, go ahead, mark off your bingo cards. I mean, they had the topping that continued pretty much all the way through the count with the giant orange external tank. You have the liquid hydrogen, liquid oxygen for that. But they had to come up with a procedure of when to arm the launch escape system and all that with Crew Dragon and everything, so that once they start fueling, if something does go wrong, they have a way out of there. And it took quite a lot of persuasion. Finally, they said, okay. And in fact, now when astronauts train to fly aboard Crew Dragon, when they're doing their dry dress rehearsals and training in Hawthorne, they will actually play the audio of the propellant loading so that they anticipate it on launch day.
I really wonder what that sounds like. It's gotta be like really cool, and also maybe kind of a little bit weird, like realizing that the vehicle that you're strapped into is physically coming alive underneath you. That's gotta be so cool.
I mean, probably.
Yeah.
How's that?
Yeah, definitely. All right, we got a few questions coming in here. We got to start off with a fun one here. Eric asking, what aren't the 4 towers for?
Brushing your teeth, flossing. Why do I have dentistry on my mind all of a sudden? I'm trying to think what else they could be not for. I guess technically, though, we should answer what they are for.
Yeah, maybe.
Yeah, the 4 towers that you see there flashing, the 4th one does flash. I can tell you that. Where I was the other day, someone asked me, "Oh, what are those 3 flashing lights?" I'm like, it took me a lot to bite my tongue and go, "There's actually 4," and go into this whole explanation to them. But yes, those hold the lightning protection system. So there's a bunch of wires that go between those towers, the catenary wires, and those basically the reason they're taller than the rocket. Lightning likes to strike the tallest thing. Hopefully they strike those towers. They go into those catenary wires, and then those draw them away from the rocket and ground it into the ground. As we've seen from Apollo 12, lightning plus vehicle equals very bad situation, and with no person on board to flip SCE to aux, it could be a bad day for rocketry.
Yes, definitely. It's a unique staple of going out to the Cape. We don't really see severe weather isn't really a threat at places like Vandenberg and Starbase, so we don't see these tall towers like this. And so one of my favorite things about going out to the Cape is maybe going down to like the Cocoa Beach Pier and looking out, and it's just this like sea of blinking lights off in the distance. So it's always really neat, with the exception of 39A. 39A is the odd one out with not having these towers. So
yeah, the other thing you don't see though out at Vandenberg is the rocket because of the fog. So you don't see the towers, you don't see the rocket.
Yes, that's also true. East Coast, West Coast. All right. All right, let's see here. Speaking of the West Coast, Kurt, you're asking, are there boosters that have flown from both the Cape and Vandenberg?
Absolutely. I don't know the number off the top of my head of them, but I know for certain that there are boosters that have flown on both coasts. There are boosters that have landed, I believe, on all 3 drone ships and have landed back at the landing zones. So I don't know the exact number. I'm sure Alex would know exactly which ones, but I know for a fact they absolutely have.
You know, there's actually also been a couple of boosters that have either started out either here or at Vandenberg and have swapped coasts and then gone back to their original location before too. It's worth noting because that's quite the trek for a booster to do that.
Definitely,
Yeah,
definitely.
they realized how bad the West Coast was and wanted to come back to the East.
You know, I want to say there's at least one booster that I believe it began life out at Vandy. It came here for, I think it was literally one flight before it went back to Vandenberg. I have no idea why that was. Maybe they had a low inventory. I'm not sure.
Apparently,
I was
that's
gonna-
1063, according to Alex in the back channel.
Yeah. I was going to say, maybe it just didn't like the East Coast, but I don't understand how anybody could not like the East Coast. So, let's keep it going here.
Eric saying, I'm telling Jack. Go ahead and tell Jack. He knows he's wrong.
I already got an angry text from him after I said East Coast, West Coast on the last stream. So, I'm anxiously awaiting the next one. All right. Question here asking, how many Merlins do we think SpaceX scraps during its testing of Falcon 9?
What do we mean scraps during testing?
I mean, in the very early days, that they were blowing up engines quite a lot because they were trying to figure out where the limits on the engine were, either in the main combustion chamber, in the nozzle, and anywhere in the plumbing or any of the pumps. So they were blowing up engines pretty often, as we used to see with the Raptor 1 and the first Raptor 2s as well as too. So engine failures are it's not a rarity in testing, but even though we have seen a lot less of them, thankfully, at McGregor, but we don't see a whole lot of Merlins fail anymore. I can't recall ever seeing one fail, because usually whenever they head to McGregor, there's either 9 of them mounted to a first stage to be fired for flight. I think it's a full duration burn, if I'm not mistaken, and they also test fire Falcon 9 Stage 2s there as well with the vacuum optimized Merlin engines too. So we don't see Merlins blowing up at all, really, ever anymore.
And I wouldn't be surprised if between flights they do take some of the engines off of Falcons to either refurbish them or inspect them, or I guess in worst case scenario send engines back to McGregor for retesting. But in terms of ones that have actually failed or scrapped, I guess in that sense, it's been a while. I'm sure there are some engines though where after they've flown, they went, you know what, let's replace this engine with a fresh one on Falcon and retired it.
Yeah. Engine swaps on Falcon 9 first stages aren't exactly, they're not common. Like it's scarce that we ever even hear about that. But the occasions that we have seen of Merlins unfortunately going to the dump or getting scrapped is unfortunately the 3 boosters that we have lost here in the past couple of years, tipping over on drone ships, which this one almost did on its very first flight on CRS-24 when it came down really hard and crunched a lot of the engine bells on the first stage. But other than that, we don't really see Merlins ever either having failures during testing or really ever.
Wasn't there a KSE flyover that you did, Max, where we saw the engines from one of those? It may have been 1058, RIP 1058, outside of Hangar X.
Yeah. It was our first flight after 1058 met its demise. I think on Christmas in December of 2023, we saw at least the engine section out in the back area of Hangar X, and then also 1062, we have also seen the engine section laying around in port, kind of by where the service cranes are that SpaceX uses to lift the first stage boosters off of the drone ships. That was over there for a while. I haven't checked, actually. I'll have to go back at my flyover photos from our last one and see if it's still there, but that was also there for a while.
The last one that's already available here at NSF's YouTube channel?
Precisely that one.
Subtle.
Very nice. Cool. All right. We got a question here asking, what is the trajectory for tonight? Interested to see if this will be visible from the East Coast. So, here you can see, as Sawyer mentioned earlier in the broadcast, tonight's flight's going to be flying to the southeast out of the Cape, which unfortunately means that if you live further up in the East Coast, like maybe in northern Georgia or in the Carolinas and even further north, you're most likely not going to be able to see tonight's mission. Normally the missions where we do see, though, if you live, like me personally, I live in North Carolina, the nights where we see these Falcon missions fly is whenever they fly to the northeast out of the Cape. However, if you live in Florida, southern Florida, or the Bahamas or the Caribbean, you're going to have a fantastic show tonight. And get a great shot of, or get a great view of Falcon 9 launching out of the Cape into orbit. If you live in any of those areas in that general region, definitely go outside and try to see it. Seeing these missions up close is really cool, like from the Cape, but seeing them also from far away is also really, really cool. So, yeah, good question there.
And I have to give a shout out to a lovely couple that I met at the last launch who came from the Carolinas down to Cars Park to watch a launch, who watch us at NSF all the time, which thank you for that. I made sure to give them some stickers, but they were saying, that they really love the ones that go up the Northeast so they can see them, but of course it's nothing like seeing it in person. So yeah, it's southeasterly. Of course, it never hurts to go outside and take a look just in case, because sometimes it can be far north toward like Jacksonville area and sometimes bits of Georgia. But for the southeasterly ones, pretty much anywhere south central Florida downwards, even usually Tampa and St. Pete, all the way down Vero, Fort Pierce, West Palm Beach, Fort Lauderdale, Miami, those areas, you'll get a good shot of it.
Definitely. Cool. We're gonna hit some super chat and support right quick. Telstar86 gifting a red team membership. If you got that membership, enjoy those perks that come with it. Guys, I think we have a booster in chat. B1062 saying, "Can Max say we tipped over? Thanks for the reminder." At least I'm still on display. I didn't know Falcon boosters could have YouTube accounts.
Yeah, me either.
Very cool. Thank you for that support. Elmarie here with Curly L's with Super Chat. Thank you for the support. Chris Ray asking a question here saying, with so many veteran boosters in service now, does SpaceX produce a set number of boosters per year or just build them as needed?
It seems like it's more of an as-needed basis. Obviously, they continue to produce new ones, especially as these get into the higher numbers of their flights, as we do more of these Starlinks. NASA typically only has crew flights allowed on boosters that have flown 5 times or less. So that's part of into consideration with the number of boosters that they have and the ones that they fly. I know they continue to make new ones anyway. I believe it was 1095 that we saw recently being tested at McGregor on our 24/7 live feeds over there. So they continue to test and build these new Falcon 9s and then ship them over to the Cape. But they've got their trusty ones that have flown a bunch that are primarily at this point for Starlinks. They have their middle of the road ones, which do some customer payloads. And then their easier, newer ones for the more demanding customer missions, such as specific DoD flights and NASA.
Very cool. It's always awesome to see the number of flights that these boosters rack up just continue to just increase and increase. It's really, really cool.
Yep, and apparently, per Alex in the back channel, they are already at 4 boosters so far this year, passing by McGregor, with 7 of them that passed through last year.
Wow, that's honestly a lot more than I was thinking they would be producing. So, wow. Very cool. Maybe we'll see some brand new baby boosters out on the Cape and in Vandy soon.
It's a rare sight. It's a brand new shiny white Falcon 9. You know what? As these boosters get older and older and fly more, it's easy to forget that a brand new Falcon 9 is actually bright white. And it's hard to tell that now because especially boosters that have flown over 10 times, their appearance on the actual tank structure gets darker and darker with the amount of soot that builds up after every single flight. But yeah, it is a rarity to see a brand new shiny white Falcon 9 anywhere, either here at the Cape or at Vandy. It's always a treat seeing one though.
Definitely. I mean, I'm partial, but I'll always love the sooty Falcon 9 boosters, but there's just something about a bright white Falcon 9 that's just gorgeous. So, I mean,
also, I think, so of the Falcon Heavies that we have launched since they came back into service in 2022, only 2 of them have utilized all brand new cores. The first of which was the first one with USSF 44, and I know D has also very good memories of that mission, and we didn't see it, but that Falcon Heavy had 3 brand new shiny white cores, and also Ghost T in June of last year also had 3 brand new white cores, and I have to say, a Falcon Heavy with 3 brand new cores is a sight to behold. It is so pretty.
And hopefully, by the way, this booster should start looking a lot more white very shortly, as if they have given the go for prop load, they will begin propellant loading in 50 seconds.
That was a very good transition, Sawyer.
Thank you.
You're about to go right into what I was going to say, is that we should see prop load starting soon. So hopefully we'll see that Falcon 9 start to get pretty frosty here soon. Now, Max, you know, what's I know we talked about the weather a little bit earlier, but now that we're getting into more of the summer months out there, what's the temperatures looking out at the Cape? I know you mentioned before stream you had to go run and get you a sweater.
Yeah, well, before I answer that question, I have to correct myself. I said goes T. I meant goes U, not goes T. Goes T flew on in Atlas 5 back in 2022. Slight correction. Yeah, so the weather actually, I've been talking to friends and family who are around the area, and we've all been saying the weather has been borderline like too good, especially in the latter half of the day for this time of year. Because normally April is when we arrive typically in the summer weather patterns here in Florida, i.e. it rains and storms literally every single afternoon on cue at like between 3 to 5 p.m. every day. And we haven't really had that at all this year. We've had a couple storms roll through, but that's it. We've had nothing else. And the weather right now is just about perfect, about as good as it can get. But as we transition and get closer to these summer months, I'm sure that weather pattern is going to rapidly change, especially toward the latter half of the afternoons. But that being said, it is lovely right now, but hopefully we are not running out of our own luck here. Because weather here in Florida could change rapidly, and we have seen that many times.
Yeah, I know we've been lucky with having such good weather with this launch and Bandwagon and CRS earlier in the week. So, I want to say I hope it'll continue, but I just know it won't. So,
just accept your fate and just move on.
Yep, definitely. Cool. All right. Question here asking, can we get a time for launch? Sawyer, do you want to talk a little bit about the windows for these Starlink missions? Because I know CRS and Bandwagon earlier in the week, those were some instantaneous launch windows, but this isn't an instantaneous launch window.
Right. With the Starlink missions, they tend to typically have a little bit of a longer window. This one, we are currently aiming for the top of the window, the opening of it, which is 9:52 p.m. Eastern Time, but they technically have all the way until 1:28 a.m. Eastern Time. That is assuming they do not start fueling. The moment they start fueling, which again, we're keeping an eye on the rocket now for any indication of prop load, so you might see some of the kind of ventiness or steaminess around the rocket. Once they do that, they are committed to the T0. So hopefully we'll know shortly if they are indeed going for the 9:52 p.m. Eastern Time T0.
Definitely. All right. Let's see.
Why did I just forget the name Frost? That's the word I was looking for. Frost.
Question here, asking how, whenever Falcon 9 gets low into the count at that T-3 second mark, how do they light their engines?
Ooh, there's, we sometimes talk about looking for the green flash at the base of the rocket. So that is something called TTEB. That is triethyl aluminum and triethyl borane. And yes, I said aluminum, not aluminium. So that is TTEB. It's like a green flash that you'll see. It's a pyrophoric thing that mixes together. And that's also what you'll see them use, to light the vacuum engine as well as typically the relights for the landing.
Very cool. All right. Max is reporting frost. Is that a little bit of white smoke I'm seeing at the bottom of the...
I'm seeing a little bit of vapor at the very bottom of the liquid oxygen tank. So we are now into prop load, and SpaceX has committed to the 9:52 p.m. T0 here from Slick 40.
All right. That should be coming up here in just a little bit over 30 minutes. So, starting to get into the business end of that countdown. A question here asking stubby tonight. I believe that's referring to the stubby nozzles on the MVAC engines on the second stage, right, Sawyer?
That is correct. The Merlin vacuum engine, they have two different variants of it. There's one with a slightly longer extended nozzle, which is what they basically have been using for the most part since the beginning. And then they have a second variant, which uses less material. It is shorter in length. It's kind of, as we say, it's more of a stubby look to it compared to the elongated engine bell. So as a result, that we call them the normal engine and the stubby engine. Now, for these flights, keep in mind, 28 is the most of the V2 Mini satellites that they have been able to carry so far on Falcon 9 of the regular V2 Minis here. So they need all of the thrust they can get. And while the stubby engines are shorter, which means less material, which means easier to make, they are slightly less efficient than the full-sized ones. So for 28 Starlinks, it's pretty much a 128.3% guarantee that it will be a regular engine and not the terrible one. I should have gone for 104.5%, which is the shuttle reference, but I don't know where my brain went.
I mean, me personally, I like the stubby nozzle. I think it's pretty cool. But
Yeah, me too.
I think it's awesome.
It's awesome.
What?
2 on 1, or we actually outnumber Sawyer for once. Fantastic.
Yep. There we go.
Well, D, I need D's help here, quick.
Listen, we see so
No.
stubby is not bad. We see so much. We see so much
Stubby
more
is good.
normal.
No,
We
back
see
me up, Chad. Stubby nozzle bad, right? Come on, help me out here.
We see.
It saves you money, it saves you material, it saves you weight. You lose a little bit of performance, but you gain, I guess, you can make up for the difference in performance if you're carrying a light enough payload, depending on where you're going. So stubby functionally is good.
I mean, all engines that get things to space are good, but I'll say regular engine is better.
So you just said stubby nozzle is not bad. You literally just said that.
I will agree. It is not a bad engine. It is just not a good engine.
It's a great engine. Bingo, bango, 3 against 1, Sawyer.
All right, let's
There's
see.
a poll in chat. Help me out here.
Yeah.
Wait, what? Oh, come on. It's biased. Who wrote this? Stubby nozzle, I'm a fan because I'm cultured, or I hate it because I'm odd. Hey, I am odd and I'm proud, okay? Nothing? No response to that? Wow.
Oh.
Take this L, Sawyer. It's all good.
Yeah, it's okay, Sawyer. It's okay.
Ugh. I'm not taking the L. I will fight, but we will continue with the countdown. Otherwise, we'll be stuck here until T0.
All right. Okay, after that bit of a discourse, we are past T-minus 30 minutes now. As you can see, that Frost is heading a little bit further up on Falcon 9's first stage, which means fueling is underway. So, question here from Mike asking, is there any chance of a jellyfish tonight? I know we saw one the other night with the bandwagon launch. Is there a chance for one tonight?
We did, and unfortunately for tonight's launch, it is flying too far after sunset to fly back into the sun's light and illuminate the Falcon 9's upper stage exhaust particulates. So there's too light in the evening tonight, and obviously if it went further into the window, your odds are obviously even more of a zero because you are much farther away from either sunset or sunrise. But not tonight, but hopefully we will see one very soon. We haven't seen one in a while. I think the one that we saw for bandwagon was a little bit unexpected. It certainly caught me off by surprise for sure because of how just high they lofted that first stage.
Definitely.
Yes, and I stand corrected from my previous stream. That indeed was a jellyfish. It was just
There
a
we
weird
go.
one.
There we go. All right. Had some support come through real quick. Some more support from B1062. We have Ethereal here with the $5 super chat saying, I suggest using chlorine triloride and dimethyl mercury as the fuel for the booster. Do we have any chemists here on stream to help us understand if that's better than RP1?
I like stuff that goes boom in controlled manner.
Okay. That works for me. That works.
Yeah.
I mean, that works for me.
My degree's in journalism. It is not in chemistry. So as long as it makes the rocket go as it needs to go, I'm happy.
Yep. Agreed. There's a close-up shot there of some more of the frost and white clouds. Now, Max, why do we see these white, like puffy clouds coming from the booster? You know, is that okay? Is that normal?
That is perfectly normal, and you know what? There is such a large temperature differential between the propellant in both the super chilled RP1 and the liquid oxygen on the first and second stages. It is a hundreds of degrees Celsius temperature differential, and because of how humid the air is here in Florida, more often than not, that temperature and moisture differential often leads up to frost or ice buildup on the first stage. That's completely normal. That is all taken into account with how Falcon 9 is constructed. That is all normal. It just looks really, really cool, doesn't it?
Definitely, yeah. I know. I always love 39A launches. Whenever all of the ground surrounding the concrete pad just sort of look like a cloud.
Yes.
It's always really, really, really cool to see that.
It's even better seeing Starship because you have a lot of vapors coming out from the tank farm and the engine chill area. Like, I think it was Flight 5 in one of the aerial views SpaceX had. The entirety of the flats, as we call them, and the dunes were completely clouded over in fog and vapor from the tank farm and from engine venting from the super heavy booster. It is a remarkable sight, but that's what happens when super cold either gas or liquid meets either a relatively hot I say hot. It's the temperatures in the atmosphere right now to us are not hot, but when you put it in perspective of the oxygen and the RP1 with Falcon 9, there is a hundreds of degree differential there. So from its reference, it is the air around here is scorching hot. So that's why you see that.
Yeah, it was really cool. I believe with the Flight 5 landing, catch. Seeing the boosters, seeing the boosters shockwave hit that, I guess, fog or smoke, or I don't even know what to call it. It was cool seeing the way it just disrupted it. It was really neat. So, yeah, white clouds are good. So. Dougal here, gifting 5 red team memberships. Telstar here saying stubby bad, more efficient but ugly.
Agreed.
I disagree there.
I mean, that's not even an opinion. That's just a fact. Like, sure,
yep.
Is it less visually appealing? Sure, but does it function as it is intended to and serve in the purposes it was designed for? Yes. So, W.
More nozzle, more better. Thank you, Telstar.
There we go. Here you go. Super chat here agreeing with Sawyer, saying stubby is bad. There you go, Sawyer.
Thank you, Ethereal Swordsman. I appreciate it. I appreciate the 31% of you that agreed with me in the vote as for which nozzle is better. So one thing we can all agree on, though, that one of the best things is definitely the non-stubby nozzle. So and Endeavor being the best shuttle.
Sawyer,
there we go, Sawyer. Yes.
Post, and what else can I throw in?
Well, Sawyer, even with that super chat, it's still 3 against 2 on your side. So
we have all of chat on our side.
We
you know
do.
what?
We won the poll. That's all that matters.
All right. And then Apocalypse Cow here, gifting 5 red team memberships. Thank you for that support. And if you got one of those memberships, let us know in chat. All right. Keeping it going here, coming up on T-minus 20 minutes. Sawyer, I think something really cool happens at T-minus 20 minutes.
Not just 20 minutes and 20 seconds. Indeed.
There we go.
Yes. So we are now exactly 1 minute away from the best vent, the T-minus 20 minute, 20 second vent. We say vent, it's more of a chill down than anything. So basically, that will indicate that the RP-1, the rocket propellant one, is completely loaded into the second stage. Now, before they transition into loading in the liquid oxygen, the LOXygen, as I used to call it and probably should call it again, they need to chill down the line because that is dramatically colder than the RP-1. So they condition the lines, get it ready for that supercooled liquid oxygen so that it doesn't shock anything as it goes through. And then once it is supercooled, it takes about 4 minutes. They then begin loading it into the tanks aboard Falcon 9. So in just about 10 seconds, we should be seeing that indication that RP-1 load is complete and that the chill down on that LOX line is underway. And if so, that means that everything's proceeding on track towards liftoff tonight.
There she blows.
There we go. That pesky crew tower is blocking our view, but we can see it. Very cool. It's one of the cooler parts of Falcon and Starship launches is that you really get a sense for how dynamic these launch countdowns are. So, very cool. A good sign that the count is proceeding normally.
Nominally, yes.
There we go. Yeah, sorry. Question here from Rockets Forever saying, why are there more launches from Slick 40 than 39A?
Who do you want to take that one? Max, you want to take this one or?
Sure. So essentially the way Slick 40 has been optimized in its design, it is optimized for rapid turnaround of flights. And we have seen that before where SpaceX has a couple of times turned around that pad and launched in under 3 days. There's a lot more to move and organize and prep over at 39A between the flame trench and the FSS and any supporting tanks or anything else around it. It just requires a lot more maintenance. And it's also the primary pad to launch crew from, so the powers that be try to be as careful as possible in what they launch from that and when. So Slick 40 is basically just as designed to be launching Falcon 9s left, right, and center every 2 to 4 days. So it is designed for rapid reuse, and so is Falcon 9, and then eventually Starship and Super Heavy.
Definitely. All right. Question here from Owen asking, how does the Stage 2 deorbit burn work? When does it happen? How is the engine restarted in space? How is the trajectory calculated? Where is it visible? How does this Stage 2 deorbit burn work?
It's basically planned out everything to the T, because you'll notice when they put out the launch hazard areas, so basically areas for notice to mariners and notice to airmen, they will basically say, hey, here's where to watch out for second stage debris. So once everything is where it needs to go, they'll do a final burn that will aim it to re-enter within that trajectory. They will passivate the vehicle, basically vent out any extra propellants on board, any excess things that may still be on there. And many people have seen that before and reported it as aliens. There was a recent one over the UK and parts of Europe that just happened. There was also one recently that was seen over McGregor of that, where it kind of looks like a pinwheel as they passivate and get rid of all that excess stuff. It then burns up, and anything that does not burn up in the atmosphere splashes down within that area. So for this particular mission, the debris area for the second stage extends from around South Africa, the Cape of Good Hope area, past Madagascar, and all the way up towards Malaysia at its farthest.
There we go. Another question here asking, now that we know that there's a hypersonic test launch coming out of the Cape soon, do we think that's had anything to do with maybe the recent holdups that we seen from the Eastern Range? I know last week was really quiet in terms of launches.
It really was. There is a launch window tomorrow morning between like 7 a.m. and I think it's around 10:30 a.m. for a some sort of hypersonic missile test out of Slick 46. But beyond that, we don't know exactly what's flying, where it's going, or really what the objectives are. In terms if that interfered with the range scheduling, I don't think we have any way to officially confirm that, and I don't think the 45th Space Wing or Space Launch Delta 45 would make much of a comment on that. I believe in one of Eric Berger's most recent articles about the matter in the recent slow period we had, he asked General Panzenhagen, who is the head of Space Launch Delta 45 here, both here in Cape Canaveral and also at Patrick Space Force Base, just south of Cocoa Beach, that she actually declined to share details on what exactly was the holdup. So it's tough to really say without getting into some serious speculation and without any official knowledge.
Yeah, I mean, it could also, it could be this missile test, but it could also be something as simple as just infrastructure upgrades around the Cape and stuff like that. So, yeah, a bit of a mystery.
Military, you think they're going to tell us?
Yeah.
Well, they might after it's done, after their exercise or whatever is finished. Then maybe they'll make some kind of public statement about it. But before then, absolutely not. Absolutely not.
All right. Coming up here at T-minus 15 minutes to launch, you can see their Falcon 9's getting very frosty and very cold.
Like Max, getting cold.
Yeah.
I'm not that cold. What are you talking about?
And see, now he's frosty.
I literally heard you say you're going to go get a sweater.
I did, and I did, and I'm fine now. But like, it's not awful. It's not windy. I'm not freezing. I'm not frosty. I'm salty. It's different.
I joke. We love you, Max.
Max, as a fellow Southerner, anything under 80 degrees, I would probably put on a sweatshirt too. So
that's what I'm saying. Like, everyone loves to make fun of everyone, especially those in Florida, for if it's like below 75 and they're a bit chilly. Come live here for like 3 to 6 months, and then tell me you don't feel a difference after a while.
I've been down here. This year will be 10 years in Florida, and I kind of get it, but it's nowhere. I think our cold tolerances are slightly different.
Definitely. All right. Question here asking, why don't we see any ground landings of Falcon 9 anymore? I get that drone ships are safer, but if the booster crashes, but when it costs a lot more to replace the drone ship, I believe we saw 2 back-to-back RTLS landings on Monday, right, Sawyer?
2 in the same day, in fact. Yes, one at 4:15 in the morning and one at 8:50 at night on the same day with CRS-32 and Bandwagon 3. The main reason with the drone ship landings versus RTLSs really comes down to what you're launching. So basically, if you are launching a heavier payload, you want to kind of land on a drone ship downrange because you can reposition the drone ship. You can't really reposition the land. So if you want to land back at the landing zones, you have to save enough fuel on board to then be able to do a boost back burn to turn yourself completely around, stop all your forward momentum, turn backwards towards the Cape, and then still do the entry and landing burns. You need extra propellant for that, so you need a lighter payload for that. For something like tonight, where again, it is a 28 Starlink satellites launching aboard this particular booster, which is the most that, tied for the most that they've launched. You want as much performance as you can to get those into the proper orbit. So as a result, it's easier to just position the drone ship downrange where the booster will be, rather than move the booster to where the landing zone will be.
There you go. Max, I have a question here, maybe about some camera stuff. Saying how close or far away is this camera that we're looking at right now, and how do they get videos up close to a launch and booster without, losing their cameras?
So from here at the KSC press site, looking over to Space Launch Complex 40 at the Cape Canaveral Space Force Station, it's a little over 4 miles. But obviously, with how flat Florida is, any distance, even over 10 miles, it doesn't look that far away at all. But here we are about 4.5 miles from pad 40. We're about 4 in from 39A. We're a little under 3.5, if not right at under 3.5. The closest we can get for viewing is just under 3, I believe, and that is somewhere on the Cape side for certain missions. In terms of how we get video and imagery from cameras at the launch pad, well, we have cameras at the launch pad that can fire and manage themselves. And basically, the most common method of doing so, at least for photography, is using some sort of sound trigger, and the most popular variant of that is what's called a MIOPS. And so essentially what that does is say your camera's asleep. Obviously, rockets are very, very, very good at making noise. And so once the engines ignite, whether it be Falcon, whether it be Atlas, whatever's launching, depending on your proximity, the sound will hit the camera and the trigger, wake up the camera, and then the bombardment of sound on the system will keep the camera firing for many seconds. In terms of video, there are many ways of triggering video, and each individual has their own method of triggering it. There's no clear-cut, like, easy answer to it. Everyone kind of just has to figure out their own systems. But we can actually get pretty close to rockets, at least on certain launch pads. For Slick 40, we can get pretty close, albeit the land that we currently are allowed to have cameras at for certain opportunities is currently going to be where the new landing zone is for Slick 40 once LZ1 and LZ2 are gone. So that is going to be interesting to see how any media opportunities for that pad are going to be handled in the future. At 39A, we can get as close as about probably a half mile. It doesn't seem like that far away. Trust me when you're there. But the closest we can get is at Slick 41, and we will actually be going back there on Monday morning for the launch of Atlas V and the first operational launch of Kuiper. We can get really close. And when I say really close, like we can get up to just about the flame trench. Like if you put a camera in the wrong spot, it's going to get melted. It's going to get hurt. So you really have to be mindful of what variant of Atlas is flying and where exactly you're going to put it, along with how the wind is behaving as well in terms of where the exhaust is going to be blown. Because solid rocket propellant exhaust, it comes out. It's like this. Well, when water meets the exhaust particulates coming out of the SRBs, it becomes a mixture of hydrochloric acid and something else that I can't remember. It's really nasty stuff, and you do not want to touch it with your bare hands because it can kind of sting. And it's also very smelly. It smells like car batteries. So Slick 41 is the closest we can get. Apologies if this is getting a bit long-winded, but we love this stuff. So essentially just be careful, and obviously the longer you do this, you understand how each rocket behaves at each launch pad, and obviously you have to factor in the weather as well. So it comes with experience, but really just be careful. Be very careful.
Definitely. I love hearing you talk about it as someone who also really enjoys photography. So
that's fun. It's always fun.
I mean, I like to think of photography as a type of art. You know, it's really neat seeing all the different types of angles and stuff. All of you Cape photographers come up with whenever y'all get access to these pads. So it's always I always really look forward to any launches where y'all get remote setup. So
yeah, hopefully next week works out, because an Atlas V with all 5 solids is going to be flying, and that is the most powerful variant of the Atlas V. It has been known to hurt some cameras in the past, depending on where you put it. So it is always a battle over there, but trust me, if you get results from there, it is well worth it.
All right, coming up at T-minus 7 minutes here. Sawyer, engine chill is set to start soon on the first stage. What's the purpose of that engine chill, and why did they do it?
Yeah, so at T-minus 7 minutes, that is when they begin, as you mentioned, the engine chill. So kind of like we were talking about earlier with the propellant lines, where they have to condition them for the super cooled propellants that we're going to be going through. It's the same deal with the engines. They are going to be going through quite the temperature shock as you get these propellants going through it and then igniting the engines. So this is starting to pre-run some of that propellant through it and basically get them ready for the thermal shock that they're about to experience. The same thing is done with the Merlin vacuum engine in the upper stage, and you'll hear them on the way uphill sometimes say MVAC chill has started. But it's basically getting those 9 Merlin 1Ds on the bottom ready for action and making sure that they don't break when you actually ignite them.
Yeah, as Max was mentioning earlier, the temperature of the propellant relative to, the outside, the atmosphere surrounding the vehicle is a difference of like hundreds of degrees. So you really want to make sure your engines and any other part that your engines come in contact with are prepared. So, Max, I think you're getting ready to have to head off and get ready for launch.
It is indeed that time, everybody, but thank you very much, gentlemen, for your company, and I will talk to y'all after launch. I'll see y'all on the other side.
All right. Sawyer, do you want to walk through the last few steps of the countdown?
Sure thing. So at this point now, we have 6 minutes to go. A couple major events that we'll see will be the retraction of the strongback. That is not the black and white kind of structure that you see there. It's hard to see it with that now in place. It's a metallic structure that leans up all the way against the vehicle. It will lean back 1.8 degrees. There will be clamps that go around the fairing that will unclamp. It will retract ever so slightly, and then at liftoff, it will throw all the way back. Following that, though, we should start getting the wrapping up for propellant loads with the liquid oxygen loads finishing up first on stage 1, then on stage 2. And then we will see one final event there as they do a purge of those lines and close it out. T-minus 1 minute, Falcon 9 will enter startup and hopefully get the go for launch at T-minus 45 seconds. One thing to note, there is no Dragon on this, so ignore the part that says Dragon to internal power. But for those who are out there watching 5 minutes from now, just so you're aware, this mission 6-74 with booster 1069 on its 23rd flight will be flying to the southeast. So that is 43-degree inclination. So basically all of the east coast of Florida, Jacksonville, then continuing all the way down, especially towards Vero, Fort Pierce, Jupiter, West Palm, Fort Lauderdale, Miami, those areas, and including parts of the west coast of Florida there as well. Keep an eye out for the launch, and if you happen to catch it, send it to us on any of our social channels. We're on all of your favorite socials.
Definitely, if you can get outside, if you're in any of those areas, definitely go outside and try to see Falcon 9 go, especially if you have a clear shot at maybe seeing its entry burn, because seeing a Falcon 9 entry burn at night is really, really, really cool. So, all right, coming up on T-minus 4 minutes here. Gonna hit some support real quick before we see this thing go off. Tailstar here saying, all hail Lord Rosenstein, master of non-stubbies. There you go, Sawyer. Ethereal Swordsman here. Actually answering some of our questions earlier about those different chemicals, saying chlorine trifluoride is the strongest oxidizer, burns almost everything on contact. And then that dimethyl mercury is a very dense fuel. Good to know. Maybe in the future we'll see some rockets that utilize those propellants.
Yep, but this one, for those wondering, uses RP1, which is a type of kerosene, and liquid oxygen. The thing that ignites it is a green flash that you may see, especially with the second stage, called TTEB.
Yep. All right. Right before we get into the launch here, I want to mention the NSF store real quick. The NSF store has some great merchandise. Here you can see one of our metal prints, a gorgeous shot there of Falcon 9 lifting through that rising sun. Some amazing shots from all of our photographers here at NSF are in our metal print collection. You can go to shop.nasaspaceflight.com and just see some of the best images in all of spaceflight, in my opinion, there. So, really cool.
Yep, we should be coming up, by the way, now on the wrap-up of propellant load. So at this point, stage 1 should be loaded up with liquid oxygen. Stage 2 should be wrapping up within the next couple of seconds. The biggest indicator to see that we are at that point will be a final vent coming from the strongback, the transporter erector. That will be a purge of the propellant lines, getting rid of any remaining oxygen that might still be in those, because as we know, liquid oxygen in this point is meant to help make things flammable, and with a big rocket going by, we don't really want that happening.
Definitely. All right, getting ever closer to the launch here. T-minus 2 minutes.
And again,
Falcon
the rock
9.
now frosty, which is what we are supposed to see. So if it looks like it's steaming and all white and things like that, that is totally normal, totally expected. That is because the propellants are just that ridiculously cold.
All right. Now, Sawyer, should we be seeing any other of those big T-minus 20-minute vents that we saw earlier as, they really wrap up the ending of their fueling here?
Just what you see right now, which indicates that
there we go.
The LOX load is complete. The entire vehicle is now completely fueled. So that is the gas line closeout. As we mentioned, purging all of those lines one last time, getting everything ready. So we have a fully fueled rocket, and we are about a minute, 20 seconds away from launch.
All right, at T-minus 1 minute, Falcon 9 should enter startup, and that's also whenever its internal tanks should begin being pressurized for flight. Then soon after that, I believe at around T-minus 45 seconds, we should get that final go for launch from the launch director.
Correct, and we should be in startup.
All right, under 1 minute away now. Gas closeouts should be happening on Falcon 9.
Yep, and again, we have to wait for those calls to come in, so it's going to be a couple seconds. But yes, we have Falcon 9 in startup. Next is the go for launch, hopefully.
Of course, we might not be able to see it right here due to the trees and stuff in front of us, but right at T-minus 3, there we go for launch. At T-minus 3 seconds, we should see a green flash. That's that T-tab igniting those engines. 15 seconds. Ten seconds to go now. 5, 4, 3, 2, 1. I believe that's ignition. And liftoff. T plus 1 minute and 25 seconds into flight, a beautiful liftoff of Falcon 9 from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida. Falcon 9 is currently supersonic and going through the period of maximum aerodynamic pressure. Of course, that's whenever aerodynamic loads are at their greatest on the vehicle. Next major milestones here is going to be main engine cutoff. That's whenever all 9 of those first stage engines on the booster shut down. That's going to be followed in quick succession by stage separation and then the ignition of that upper stage Merlin vacuum engine. Of course, you can see the... Oh, go ahead, Sawyer.
No, I was going to say, love as it gets to the thinner parts of the atmosphere here. Yep. You see the plume expansion and the colors change, too.
That's, of course, due to atmospheric pressure and density just getting lower and lower as Falcon 9 gets closer and closer to space. Beautiful shot of that plume there.
Oh, the beautiful blue should be coming up on Miko. That is main engine cutoff. And again, there's a slight delay from the SpaceX feed from our actual cameras. So even though we saw Miko with our eyes, we'll see Miko with their cameras here in just a second.
Stage separation confirmed.
And there you can see that stage step.
Back ignition.
And there we go.
And there's that green flash we were talking about, too.
That MVAC upper stage engine has ignited. So, Sawyer, do you want to talk a little bit about what's going to be happening next with the booster as it heads in for its landing?
Sure, well, you can kind of see the fairings making their way through the bottom of that plume.
Very cool.
So you see the stars obviously going behind it, but those dots there are kind of tracking with it. See those 2 dots there?
There's a great shot.
Dots. Yeah, you can see those are the fairing halves that are separated away, exposing the satellites to space. So now this will continue. The second stage on this one will just basically continue with one long burn for about 8 minutes and 40 seconds or so. Meanwhile, the second stage is now getting ready towards reaching the top of its apogee, the highest point in its trajectory, at which point it will then pick up speed again and then lower itself towards Earth. Once it starts picking up speed, though, of course, it needs to slow down again. So at about 6 minutes and 20 seconds into flight, it will start an entry burn on stage 1 to help slow itself down. And then a couple seconds later, we will see a landing burn, with it hopefully touching down on a short fall of gravitas.
Here we go. Over 4 minutes into flight now. There you can see stage 2 is now in space, and so is stage 1. That's one of the interesting parts, I guess, of these launches, is that even though, you might think that these stages automatically just fall back into Earth, they continue to rise and keep going and going and going because they have all this speed going up. And that's one of the complexities of actually bringing these boosters back and landing them.
Just a little, and as you can see there, it hit 124, now back down to 123. That is apogee, so it is now crested the highest point that it will fly, and hopefully it will now touch down about 600 kilometers downrange on the drone ship in about 4 minutes from now, a little less.
All right, everything looks to be progressing nominally.
And that second stage tonight, man, the expansion on it has been absolutely beautiful too. So it's always good to see in space as it expands. It's quite a view from the ground. Again, if anyone catches it, please send it to us on the socials. I love seeing people's views.
Definitely. I know sometimes there's I don't know if the moon is out at the Cape, but sometimes the moon maybe does a little bit of a normal, like a jellyfish effect, like the sun does, and we get what we call a moon jellyfish. Maybe it looked like there was maybe a little bit of that from our Cape cameras. Those are always really neat to see.
Moon a couple weeks ago, so it's not totally full, but still,
yeah, definitely.
I was just about to say we're about 30 seconds away from that entry burn, but yeah, to see that second stage plume expansion is always spectacular.
Yeah. All right, should see that first stage entry burn start up here in just a few seconds. That'll slow that first stage down as it continues its re-entry into Earth's atmosphere.
Go
rather,
ahead, folks.
entry.
You know the saying that we like to say here at NSF. How does it slow it down? Fighting fire with fire.
Stage 1 entry burn startup.
There we go. We see those engines igniting.
So there's one engine, and then now it's all three.
Really neat to see that.
Yeah, so basically it's using the flames around it to kind of act as a mini heat shield. So that's why we say fighting fire with fire. So by flying through, it's cutting its way through the atmosphere and preventing itself from overheating.
Yeah, and we saw those grid fins right there. What are the purpose of those grid fins, Sawyer?
So as it gets into the thicker part of the atmosphere, those will help steer the vehicle. So basically, once it gets down towards the barge, it doesn't aim directly at the barge. In fact, it aims next to the barge. And then once it realizes that all systems are good, all of the engines have lit as they're supposed to, it will then steer itself towards the where the X used to be, at least before it got burnt off from so many landings on the drone ship. So you'll see them wiggle as we get closer.
You can actually see a little bit of that that plasma building up around those grid fins, those little flashes there. As the air around the booster continues to heat up as it gets into denser parts of the atmosphere.
And that light that you see is the drone ship through one of the grid fins.
Very cool. All right, coming up on that landing burn, and then soon after that, we should see that second stage engine cut off.
Yeah, they happen pretty quick back to back.
Stage 2 terminal guidance.
See that drone ship getting closer and closer.
Stage 1 landing burn.
And there we go, there's that landing burn. You see the deployment of those 4 landing legs here in a few moments. A great shot there from the drone ship.
1 landing leg deploy.
There's those landing legs. And touchdown. Another booster recovered.
Stage 1 landing confirmed.
Beautiful work by SpaceX.
Oh, it's a little wiggly on the deck there. But it is on the deck, it looks like.
All right, and let's see. Get this second stage engine cut off. There we go. And there's the shutdown of that Merlin vacuum engine.
I have to hold
Hey.
my breath a little bit with that landing because, for those who know, our friend Alex is in the United States, and sometimes the missions don't go fantastic when he's here, but we had nominal orbital insertion, which means all went exactly as planned.
Ouch.
Beautiful. Max, do we have you back on comms?
Indeed you do. How do you have me?
Good. How was lunch?
Beautiful as always. Haven't seen that in about a week, and it was honestly, it was dearly missed. So it was a very pleasant sight as always. A gorgeous night to watch one, and we saw it all the way down to entry burn, at least for the first stage. As Sawyer was saying, we do have to hold our breath a little bit because Alex is in the U.S. and we all know how well that went last time. So, but all jokes aside, no, it was beautiful. It's always a pleasure to be out here.
Definitely, and this is always one of my favorite shots of a launch. Empty launch pad, no rocket. That means it's on its way with the next batch of Starlink satellites. Now, Sawyer, I know you mentioned it at the start of the stream, but these Starlink satellites are going to be going to the Group 6 shell, correct?
Exactly. So that is a 43-degree inclination. So when we say inclination, think the equator is 0, going straight up and down is 90. So this is 43 degrees at an angle. So going southeast in this case, basically draw a line 43 degrees from the equator. And that's the kind of orbit that these will launch into and the shell that they go into. And typically for this shell, we have 28 of the regular satellites. There are the direct-to-cell, and then there are the regular satellites. These were all the regular ones. And of course, we will have our regular spectacular replays coming up momentarily.
Yes, I can't wait to see what Max and D got out there, as well as some of our other cameras out there. All right, in the meantime, you want to hit some more questions, Sawyer?
Sure, let's do it.
All right. So, of course, with this not being a Dragon mission, Falcon 9 launched with its fairings. And we have a question here asking, how do they recover the fairings if they don't have heat shields on them?
So, when you think about the way that the fairings are, they're kind of designed to punch through the atmosphere just like that. So, the material that they're made of is designed to withstand those extra forces and the extra heat. So they will kind of basically go flat side down, and they have a couple of thrusters that will help actually steer it to its planned landing zone. So they will kind of steer it, aim it in that right direction. It will cut through the atmosphere with that flat side down, and then it will splash down with a parachute, of which Doug is currently the SpaceX vessel downrange, to literally go scoop them up and then bring them back to port to fly again.
There you go. Question here, given that we just saw Falcon 9 land on one of their drone ships, saying, will we ever see a double drone ship landing during a Falcon Heavy mission? That'd be very cool.
Ooh,
I believe that was the original plan for USSF 44, but for reasons that we are still not privy to, they opted to do a double LZ1, LZ2 return to launch site with the sidecores. Maybe we will at some point if the performance needed calls for that, but you need a lot of accuracy with that because those sidecores will be going a bit farther downrange than they normally do, and let alone they have to avoid each other as well. So I wouldn't rule it out, but you never know.
Okay, they learned the hard way with the center core that goes even farther with even more velocity that they have to bleed off. That trying to land that on a drone ship didn't go so great.
I mean, they did once, and then it fell over on the way back. Remember?
Minor detail.
Nah.
Minor detail.
All right, let's keep it going here. We have a question here asking, can the recovery hardware and the fairings be removed to increase internal volume?
I don't think so, because again, I think you're more limited to just the diameter of the vehicle. I don't think you're going to get that much more space by getting rid of it. So when you factor in all of the insulation that's already there, you factor in the doors that are used for access, all of the cabling that needs to go in there to be able to get data, and environmental systems for all of the payloads on board. I don't think you would be saving any real volume by getting rid of it. So at that point might as well save the money and recover them, because those are, last I saw, about what, $1 million a piece minimum.
Yeah. Yeah, Alex in the back channel saying they would in fact just uninstall the installation before removing the recovery hardware. So yeah, looks like they're they're really committed to recovering these fairings. So, but that's really cool to see. I know we've seen some of these fairings, I believe, ever since we've been able to track them with their serial numbers. We've seen them, in fact, go, I think, up into the 20 or so flights. Am I wrong in saying that, Sawyer?
We've seen ones very close to 30. I don't think we've seen a
Wow,
30 yet,
okay.
but they've got, I can remember off the top of my head at least a 28. And we'll go to Alex with the spreadsheets with the actual numbers.
I see him typing the back. Yep, there we go. He said he thinks this flight had a fairing on its 29th flight. So we're getting very close. Right. And actually, yeah, keeping with the fairings here real quick, having a question, you're asking, how do we know the flight count of the fairings? How are we able to track these fairings?
Well, a lot of it comes down to the amazing Cape team that we have down there, all of our Space Coast Live 24/7 cameras, all of the amazing work that's done there, and of course the people who keep the spreadsheets of all of them.
There you go. Of course, Space Coast Live, our 24/7 cameras that we have down there at the Cape. You can check that out here at our YouTube channel. Okay. Continuing with some questions here. D Dolphin Productions asking how hot are the combustion chambers of the Merlin engines? Is it as hot as a lava chicken?
No, not even answering that.
I think we can say it gets pretty hot in there.
I haven't even seen the Minecraft movie, but do I dare say chicken jockey and see what happens to chat?
Oh no. I missed a flint and steel earlier, and Ryan got mad at me in the back channel, so. All right. I know we no longer have a Falcon 9 on the pad, and we're not watching fueling anymore. But Mike, you were asking, how long does it take to fuel up each stage?
Again, it's sort of a staggered fueling for stage 2, but the entire vehicle from start to fully fueled is about 33 minutes or so. And what still boggles my mind is the fact that when you factor in not just Falcon Academy, excuse me, Starship, of how much larger that vehicle is, how much propellant is needed for that, and the fact that that loads not much longer. We're talking still under an hour, I believe, is just mind-boggling, the numbers.
And mind you, the goal for Pad B and its tank farm is to fill the entire vehicle, both Super Heavy Booster and ship, in under 30 minutes.
Wow. Yeah, and I know earlier we were talking about the advantages to really going with that load and go procedure really allows SpaceX to achieve such a rapid launch cadence. So, yeah. Question you're asking, what was the purpose of this flight? I mean, we no longer have a rocket on the pad, so if you're just now joining us, sorry, do you want to give a brief overview of what this mission was launching?
And you'll see the replays too. You will see the replays. So hang tight. So if you missed it, don't worry. You're going to get even better views than what you saw just live, because you got to see all the cameras. But yes, this was 28 Starlink V2 Mini satellites. So in case you're wondering why, it has to do with the internet constellation Starlink. Obviously, you've probably heard of it, but if you haven't, it is a bunch of satellites that provide internet to people here on Earth. You get a satellite that you get to use at home to basically receive it, and it provides surprisingly fast internet, I have to say, as someone who has used it. And then there are, I believe, about 5,000 or so satellites plus up there. I think it's over 7 now. I'm sure the number, you can see it coming up in This Week in Spaceflight when we go through all of the numbers. But But those then help provide the internet. They are in such a low orbit, though, that over time the orbit decays and they intentionally burn up and get destroyed. So as they do, they need to be replaced, which is why you see as many of these Starlink launches happening as you do.
There you go. And then a quick question about the a quick question about the Starlink satellites actually flying on this mission. Question you're asking: are these satellites carrying the newer 10? I forget what this unit is. GBPS laser terminals or the 100 GBPS hardware that we saw on 653.
The gigabits per second.
There we go. Thank you.
GBPS.
I did not know why I do not know why I blinked on that.
Internet speeds, it's fine. Then again, at home, it doesn't matter. You'll still probably get like 100 meg if you're lucky. But I would imagine so. I'm not sure off the top of my head, but it seems like that's the case with these newer ones, especially with these Group 6 launches. I'm sure Alex will correct me if I'm wrong on that, but I believe so.
Yeah.
Alex saying, I have no idea what they're talking about.
Have we finally stumped Alex?
I'm not sure. Again, unless they're referring to the direct-to-cell capability, which is which uses a slightly different antenna on it as well, which those are larger, in which case these do not contain any of the direct-to-cells. Typically for the Group 6, it's a different antenna that's used on the direct-to-cell for the actual LTE coverage, as opposed to these used for the direct internet side. But I'm not sure then specifically otherwise.
Yep. Here we go. All right. Question here asking, why doesn't the booster slow? Well, I'm assuming why doesn't the booster's velocity slow to 0 at apogee? We see it build up its speed whenever it plummets to Earth and then go through entry burn, but why don't we see its velocity just go to 0 at apogee?
Sounds like a physics question.
I'm assuming. I mean, its vertical velocity definitely would have to reach 0 in order for it to come back. But I'm assuming you're referring to the velocity, I guess, graphic that was on the space that we saw, and I believe, it still has speed there because it has horizontal velocity. Whenever these rockets launch from the Cape or anywhere going into orbit, they have to do a pitch over. That's why if you listen to these rocket launches, you'll hear them say, pitch program underway or something about the pitch. And that means that these rockets, as they get higher and higher into the atmosphere, they have to gain horizontal speed to get into orbit, because orbit is essentially just a continuous state of free fall, and you're just going fast enough to where eventually you will re-enter Earth's atmosphere due to atmospheric drag and such. But if you're around, per se, the moon or another planetary body with 0 atmosphere and no atmospheric decay, then theoretically your orbit will never decay and you'll just stay in orbit forever because you're going fast enough to where you never fall back down. So
it's combined vertical and horizontal speed, basically, versus just vertical speed.
Yes. So we see there's still being some velocity there with the booster at whenever it reaches apogee, because it's still moving downrange, because it's pitched over horizontally going downrange. And so it's still moving horizontally, even though its vertical velocity has hit 0. So, good question there. Allowed me to talk a little bit about physics, which I dearly love. So,
had a feeling you'd be the perfect one to answer that.
Yep. All right. Quick question here. Asking, are booster static fires on hold due to the tripod dismantling at McGregor?
I don't think so. I mean, we just had a booster that was recently finished up there, if I recall correctly. We had 1095, if I remember. So at last I heard, no, they're still firing away, and you can watch them for yourself at McGregor Live 24/7. So yes, per Alex as well in the back channel, they have had lots of tests even since they've started taking it down.
Yeah, the tripod hasn't actually held a booster test since like the early Falcon 9 days. It's been primarily utilized for the development of the Raptor engines, and it has since been decommissioned from that duty, although it is still standing. So yeah, it hasn't actually seen a booster in quite, like, I think it's been about a decade since it's last seen a booster on top of it.
And we may actually have word on a recent test of that coming up soon. Hint, hint, wink, wink, nudge, nudge.
Stay tuned. We got some replays coming up. All right. Oh, and we can actually see the transporter erector there going back up. It's about to disappear behind the crew tower. Yeah.
Of course, it knows that we were talking about it, so now it makes it harder to discuss it now that it's gone away behind the crew access tower.
Yeah. All right. Question here asking, is SpaceX recovering all of its fairings that it's launching?
For the most part, yeah, I haven't heard otherwise. They attempt to recover all of them. There's a passive side and an active side, the one that does the pushing and the one that gets pushed. Those parachute down, as we mentioned, they get scooped up, placed onto the ship, whether that be Bob or Doug. For today's launch, it's Doug, and bring them back. I'm sure there's some that may not have made it back in the best of shape, and maybe they've retired, but they try and get as many and as many as they can, basically.
Yeah, Alex in the back channel saying they've so far not canceled any fairing recovery attempt for a long time.
We were saying,
All
by
right.
the way, you were asking about those tests over at McGregor.
Yes, I believe there was a test that occurred literally as Falcon 9 was launching.
Almost
And I
like
believe this is
P0s.
yeah, I believe this is a replay of it. I think we got some sound with it too. See if we can see this test.
Any second now.
Oh,
Here we
there it is.
go.
And the sound. Reminder, that is a single Merlin engine we're talking here.
I believe, and this was occurring literally as Falcon 9 was lifting off from Slick 40 with that Starlink mission just 26 minutes ago.
So there were 10 Merlin engines firing at the same time on and about to be off the planet. And that's not counting the Merlin vacuum. If you count the Merlin vacuum on that flight, there have been 11 Merlin firings in the last hour.
Wow. All right, I believe this is from one of our SCL cameras. This is a shot of Falcon 9. I believe this was tracked robotically by Gage. Beautiful shot there.
I love where you can see that hot glow, yeah.
Yeah.
By the way, if you like those Raptor tests, make sure you check out McGregor Live, our 24/7 cams over there. And just as a reminder, don't forget when you have the tab open, because you'll forget and you'll be listening, and all of a sudden you'll get absolutely blasted with engine sounds, which is a pleasant surprise, but also can be quite scary.
Yep.
Totally hasn't happened to me before.
One of my favorite parts about this camera is like we get a really good view, as you can see it happening here, of the plume expansion and the color change as it gets higher and higher in the atmosphere.
And just to bring it all full circle, so we just saw the test of McGregor, and Gage was tracking this from Starbase of the launch at Cape Canaveral Space Force Station in Florida.
Here's a shot from the port, turning night to day.
This is what it looks like when you're there in person at the port. If you're eating at Rusty's, which is where we have our cameras up, great place to grab a quick bite to eat and watch a rocket either launch or be taken off of the drone ships there. It really does turn the whole thing into day. You just see how bright the whole area gets.
Yeah, night launches from the Cape they're really something special. If you Day launches are always great, but night launches are phenomenal.
Also, with the way the lighting is tonight, how it looks like a giant X on the X marks the spot. SpaceX
Yeah.
marks the spot.
There we go. I believe this is another one of our SEL cameras.
That is from the press site that we have, one of our automatically tracked cameras.
Very cool.
And yes, Amy's saying sound is the best part of liftoff. The sound
Definitely.
is spectacular. I mean, the launches themselves are gorgeous too. You can't ignore that. I mean, look at these replays. That should explain enough just how nice they are.
I think we got a little bit of audio.
We'll get to the one with the really good sound, I'm sure, in just a bit.
This is from the press site as well, right, Sawyer?
Absolutely. This is also from the press site, one of our other robotic cameras, which again, you'll see these moving around on Space Coast Live as well, 24/7, positioned at different pads, things like that, looking over the NASA media building there. And there's that is not the sun, folks. Someone did not start moving the sun.
That is just a Falcon 9. This will be a great view of how bright it gets.
Whoa, that is a hot view. I promise it does not look like a nuclear explosion.
I think this camera might just be a little bit overexposed.
Yeah, but it's okay. Don't go to the light, folks.
Cameras are hard. Sometimes they get a little bit overexposed.
Yeah, well, that's why we have our humans doing the work on the manual tracking like this one.
See all of that. Those condensation clouds briefly illuminated by that engine exhaust as it was heading up.
The view uphill, absolutely. It really is an uphill battle, but
We're going to actually see a little bit more of this specific track right here in a slow-mo that D took, and I cannot wait to see that. I know D slow-mos are always absolutely stunning.
Yes, if you're a regular here at NSF, you know exactly what we're talking about. If you don't know, stick around till just before the credits roll. Trust me, the slow-mos are spectacular. But now this one, another great shot of the launch. This one tracked by our own Max Evans.
I do love sometimes whenever we leave, I know that Max is tracking now, but I do love sometimes our static cameras that look at the pads, gives you a sense of how bright it actually is at the pad and how much it illuminates the surrounding environment.
Let's listen to that sound again.
Gorgeous sounds, gorgeous track. Beautiful shot there, Falcon 9 going supersonic.
I love, you could see as it goes through the speed of sound and hits max Q, you get that plume, gives you kind of an idea of where you are in flight.
Yeah. I believe this is a fantastic view of that plume expansion and color change. Love that you can still see a bit of that vapor trail right there. Phenomenal track,
orange.
Max.
And blue. Number of times my family will just shout, "It's orange!" at something now.
Intro, yeah.
Spectacular work by the Cape team tonight. Max and D with the excellent work, and wait until you see the slow-mo.
Definitely. Of course, this is a Falcon 9 that launched a little bit over 30 minutes ago with a new batch of fresh Starlink satellites going to help give some internet to people. All right. Beautiful, beautiful replays there from all of our Cape team. Want to hit one last bit of support we got right here. $10 super chat from Ethereal Swordsman. Sawyer, you know all that talk we were having about chemistry and stuff earlier? Well, it was all a joke. The chemicals and stuff we were talking about are actually pretty nasty. So maybe we won't be seeing them used on rockets. But nonetheless, thank you, Ethereal Swordsman, for all of your support tonight. We greatly appreciate it.
That's what that white glow was in the replay. They were using those chemicals.
Definitely, definitely. Oh, me. Well, it has been a beautiful night, Sawyer.
It absolutely has. Love seeing that. Love seeing the view. And the best view now, according to DOS, an empty pad.
There we go. All right. Well, with that and viewing all of those gorgeous replays and a beautiful launch tonight, I think we're going to wrap it up here. Sawyer, thank you for joining me.
Always a pleasure. Stay tuned for the slow-mo. Don't leave just yet, but always a pleasure being here. Great to be on stream with you again.
Yes, I know. I think this is what, the second in a week?
Second in a row, yeah.
Oh, yes, second in a row. That's right, bandwagon. Very cool. Always a pleasure talking to you, Sawyer. Out in the field tonight on comms with us was Max Evans. I'm not sure if he's still on comms with us. He might be doing some camera stuff. But, of course, always happy he's here. Joining him out in the field was D-Wise out there. And as Sawyer mentioned, stay tuned. D got an incredible slow-mo that you're going to see in just a few moments. In the back channel, Chris Atherton pushing the buttons, pulling the levers, making sure everything looked good tonight and was operating properly. And my name is Hagen Warren. I was your host tonight, and we will see you all for the next launch. See y'all later.
And here we go. We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Rolling up. Roger, planet.
Water towers fly! Yes! Tango down to nominal.
Flight downside FD off. Bring in FD off. Off. It's orange!
Oh my god! Oh my god!
Decollage.
What is it?
Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
If there's methane, it'd be igniting in the flare, correct?